Hey there and welcome to the Code Wrinkles channel for a brand new Blazor video. What I want to do this time is something that I think it might be very interesting. It would sound maybe a little bit easy, but I believe it's really important that we get the fundamentals right. So what we will do in this video is we will implement basic CRUD operations with Blazor WebAssembly. And what I want to do here is to offer a complete walkthrough actually from how we need to set everything up, because you know, Blazor WebAssembly is actually a single page application framework just like Angular and other such similar frameworks that we have outside. So when we talk about single page applications, we usually have in mind an architecture where we have an API backend and we have this single page application, the front end, that needs to talk actually to that API backend to get some valuable information from it in order to be able to display something. And what I want to do is actually to set everything up using Blazor WebAssembly. And of course, to do that, we would also need to create an API layer. And in order to have some real CRUD operations, we would also need a database. So what we'll do today is actually we'll start from the Blazor template and we'll create the template actually from scratch. And then we will add the database layer. I would say it would be a very simple one, of course, not a complete repository pattern and things like that, but we will set the database layer up, then we will set up the controllers that we need, or the controller that we need in order to implement our basic CRUD operations. And last but not least, of course, we will implement the Blazor components in our Blazor WebAssembly app using an HTTP client or a data service or a minimum version or a viable version of a certain data service to get data from our API and display it, of course, and do something with the data in our Blazor WebAssembly application. So without further ado, let's get right into it. And yeah, let's open Visual Studio and start a new application from scratch. So we'll select here, of course, Blazor. Then we'll have to choose a name here. Let's call it Blazor CRUD. That would be the name of our application. And of course, here we have to choose, and this is actually the reason why I wanted to also go through this step of creating the template or creating a brand new solution, is that when we have this, we of course need to check here that we want a Blazor WebAssembly app. But then the important thing is that we also need an API backend for that. So in order to have this, we have to check here this checkbox that says ASP.NET Core hosted. And what this will do is actually it will provide us with a solution containing a project for the server or for the API that we need, and another project for the Blazor WebAssembly, of course configured that when you run the application, it will also serve the Blazor WebAssembly application from the server. So let's click create here. And it will take just a few seconds. It shouldn't take too long. So we'll be able then to look into what we actually have here and yeah, actually start working with it. So we don't need this at all, the CS profiles. And let's first examine what we actually have here. Because in this solution, you see that we have 3 different projects. And their naming is, I would say, fairly okay, because we have this Blazor CRUD client, which is essentially our Blazor WebAssembly app. And we can see that by the fact that we only have this program.cs file. We don't have a startup.cs file in Blazor WebAssembly. And then we have this Blazor CRUD server, which is of course the server application. So that's the place where we'll actually create our basic API layer. So our Blazor client will talk to our Blazor server via a REST API. The Blazor server, the ASP.NET Core API will get or will use Entity Framework Core to actually talk to the database, and will of course respond with JSON. And then of course the Blazor client application or the Blazor WebAssembly application will get that JSON data and will render it or will do something with it in the specific Blazor components that we will implement. And besides these 2 types of projects, we have here another one, which is actually a, well, plain class library, which is a Blazor CRUD shared. And that's the whole idea, or the very nice thing about using Blazor WebAssembly is that we can actually reuse the code that we write in all in all the other layers of our app. So for instance, if we need to use classes from the domain layer, maybe, I don't know, we can easily do that because it's just as easy as referencing this Blazor shared project in the Blazor client app and in the Blazor server app, in this case is a Blazor CRUD server app. It's a regular ASP.NET Core server here. So we can reuse this weather forecast without the need to re-implement it in the front end. And this is one of the main advantages that we have in comparison to using other single page application frameworks that are JavaScript based, like Angular, for instance, where in order to do that, we would actually have to rewrite our models also in TypeScript, because this weather forecast class that we have here in shared, we would have to model as an Angular TypeScript class in order to be able to use it. So the advantages, as we can see here, is that when we go for Blazor, we don't need to do that, because we can simply reuse the models that we have in all other layers, or we can reuse all the classes and functionalities that we have in all the other layers of our application. So let's get started, and we'll take it step by step, as said. So first we're gonna implement the data access layer. It will be a very basic data access layer. Then we'll implement the controllers, of course. And last but not least, we'll jump over to the Blazor CRUD client application, where we will implement the necessary components, and we will talk to the API and get data from the API in order to use it in our Blazor WebAssembly application. So yeah, let's get started. First of all, what we would need here is, once again, we are in our ASP.NET Core project that will serve our Blazor WebAssembly app, and will also expose our API endpoints that we would need. So here what we want to do is we want to install some packages, of course, because we want to work with the database or with a SQL database. So what we would need to install here, sorry, I have to switch here my NuGet source to all. What we would need to install here is, of course, we would need entity framework core. So this is the first package that we would need to install. We would need to install then Microsoft Entity Framework Core SQL Server. It should be somewhere here. Relational abstractions, design, SQL Server, this one. And we'll also need to implement the Entity Framework, or we will also need to install the Microsoft Entity Framework Core Tools NuGet package, because that one contains the CLI tools that we actually need for the package manager console in order to be able to run a migration, or to perform a migration, and of course update the database. Things that we will of course need to do in our app right now. So we have installed all our packages that we need, and this should be actually okay. So we wouldn't need any other package here. So the next step is that we want to implement a very basic data access layer. So we'll create a new folder, and I'll call this folder very simply DAL from data access layer. We won't implement an entire repository pattern. If you want, or if you are curious about how to implement the repository pattern with Entity Framework Core, then we have another video where we talk exactly about this, and I will leave the link to the video in the description of this video that you are currently watching. So if you want to find out more about repository pattern with EF Core, then you will find the link below in the description. So let's get started here. We would then first of all need to create a new class, because we will need a DB context, of course. So let's create a new class here in our DAL layer, and we will call this weather public class. That one would inherit DB context. Of course, we would need also to add necessary usings for that, which is Entity Framework Core, and that should do it. And the minimum that we need here for a working DB context is public. Oh, sorry, I didn't give it a name here. Let's just rename the file. Sorry for that, I wasn't attentive at this. And we'll call this weather DB context. And let's rename all the content of the file. Okay, so what we will need here, we will get here some DB context options, where we will essentially have right now the connection string, but of course you can configure different other things there as well, and we'll just pass this to the parent, okay, or to the base class. And in the constructor we won't actually do anything else, and the only other thing that we would need is to expose the db set public, and it would be a db set of weather forecast. And this weather forecast is from this Blazor CRUD shared project, so from our class library, so we have to add a using also for that. And let's call this property forecast, and then get and set, and we should be good to go. So this is actually, as said, the minimum that we actually need for the DB context, so nothing else actually. So then what we need to do, of course, is we need to go to startup.cs, and in this startup.cs, of course, we would actually need to add to add the DB context as a service. But in order to do that, one other thing that we need to do is we need to provide in our app settings the connection string, so that the DB context knows exactly to which database it should connect and perform the different actions that we will want to perform. And for that, I already have created a database. It's in the regular Visual Studio SQL Server Express, so nothing very fancy. But let's go to the app settings.json, and to make things easier for us, let's create here a property which is called connection strings, which is also suggested by Visual Studio, and we'll create here a new one which is called default, and here I will paste my connection string, and that would be it. So that would be it for the app settings. And then what we need to do, of course, is actually use this DB context. But before we can register it, we need to get the configuration. So we'll say var cs from connection string equals configuration, and we have here an extension method which is called get connection string, and we should specify which one, and we called our connection string default, so we will get that one. So what we will do next is services add DB context, and this is a generic one, of course, and this is a weather DB context. We will need to add, of course, the necessary usings also here, Blazor CRUD server dal, and we'll have here to pass the options, of course, and it is use SQL server. For this one, we will also need a using, and then we'll just have to pass in the connection string, and that's it. We have our database right now. So what we can do as a next step, of course, we can add a new migration to it, so that we create our tables. In this case, we'll create only one, which will be called weather forecast. So we'll say here add migration initial. Let's hope that everything runs okay, but it shouldn't, and it also shouldn't take long, of course. So while we're waiting, we will think a little bit of what we need to do next. So after we perform the migrations and everything related to it, what we need to do is, of course, to specify or to go to the controllers. And here we got an error. Okay, require primary. Okay, yeah, I totally forgot that. So in order for this to work, sorry for that, we need here in this model weather forecast, we have some properties, but of course we need an ID for that, because otherwise EF Core can't figure out exactly what should be used as a primary key. And following the conventions, we won't do any fancy stuff right now, so we'll just create a new property of type int that would be called ID get set, and then EF Core would consider this as a primary key. And let's run the add migration command again, and that should be it. Yeah, sorry for that, I totally forgot about this. I was so excited about what we want to do actually in this video that I totally forgot that we need to actually also add the ID to our weather forecast. So in case you ask yourself, what we did is simply we added this ID to the weather forecast model, and that's it. So nothing very fancy. Now you see that the migration completed successfully. We also got the migration class here, where we can see exactly, okay, what will happen once we update the database, and we guess that should be right. So the next step, update database. Hopefully I typed it correctly, and everything should be fine, build successful, and done. That's it. So right now we have the database set up, everything is okay. So the next step, so step number 2, is we need to go over to the controllers and implement the weather forecast controller. So let's go here to this weather forecast controller, and we will change some things here. So first of all, we won't need this stuff anymore. We get here the logger, but one other thing that we would need to get here is the DB context. So I would add here a private read-only field of type weather DB context, and we'll call this CTX. Of course, we will need to add unnecessary using for that in the dull folder, and of course we need also we hope that ASP.NET Core will inject this into our constructor if we require it. So weather DB context, and we just assign it to the field. So everything is very standard and regular, very beginning stuff for an ASP.NET Core API. Now what we'll do here is, okay, there is here some fancy stuff going on, but I don't really want to do this way. I want to go the classical way. So what we'll get here is, for the HTTP GET, we'll get an async, because we'll work with the database. So it is an unmanaged connection, so we'll use async and await. So async, then we'll return a task of I action result, and here we'll see get. What we will do here is actually var forecasts, where forecasts should be fine, equals context forecasts to list async. For this we will also need, of course, to add unnecessary using, which is entity framework core, and of course we need to await this. And after we have this, we can just return an OK, and here in this OK we'll just return the forecast. So we should be good to go with this one. Now the next one, I would like to have this get by ID. So it will be public async task of I action result, of course, and we'll call this get by ID. What we'll need here is, of course, an ID, and we'll get this from the route. So it's a regular ASP.NET Core API, as said. Let's specify that it is an HTTP GET, although this is not really required, because the default would be to consider that we want to do a GET if we don't specify anything else. But what we need to specify here is, of course, the route. So in the route, we would still need to specify that we want to get an ID from the route. And since we talk about the route, I want to do a slight change also to the route here on the controller. So it would be under API/controller. And then what we need to do here is, of course, var forecast equals await context forecasts where. So we specify the criteria that we actually want. Let's use an f from forecast, and we look for a forecast which ID is equal to the ID that we actually get from our route. And then, of course, first or default async, because we want, as said, to do everything asynchronously. And once we have here everything, we can just say return OK, and we'll return this forecast. And that should be it. Now, the next controller action that we want to implement is the create one. So let's have it public. It will be an async task, of course, of I action result, and let's call this simply create. Here we'll also have to specify that, okay, we want this to be an HTTP post, of course, because we want to create something. And the route should be the regular controller route, so nothing else here. But what we need here is that I like to specify that from body, I want to get a weather forecast that I actually want to create. So what I will do here is I will say here simply context forecasts.add, and I will add the forecast. Of course, I don't do any type of validation here. This is only, as said, I just want to go through all the steps to set everything up, but this is not really a complete how-to, and this should be done exactly like this. I just want that we stick actually this type of thinking that we need to implement the database, the controllers, and then to implement the components that actually talk to the API behind it. But of course, in the controllers, there is regular best practices, or there are regular best practices that we use in ASP.NET Core. And by the way, the month of February, as per the voting to the poll that I posted recently, we will only create videos, or mostly create videos, on regular ASP.NET Core. So if you are interested in different topics on ASP.NET Core, like for instance logging, services, service lifetimes, which is very, very, very important, maybe also a little bit HTTP, but maybe also some things about views, partial views, things like that. During the next month, we would actually create only or mostly videos around ASP.NET Core. So for now, we just add this to the context, then await context save changes, async, of course, and this is actually when our change gets written to the database. So right now in this line, so line number 45, we just add actually our new entity to the context, but this entity is written to the database only when we call this save changes async method. And then what we will do is return okay. And once again, this is not the best practice. In a regular REST API, you would return a created result here, but I just want to keep things as simple as possible here. And so what we will return the created forecast, which after the creation, of course, will also have an ID. When it will come here, it won't have an ID, or the ID will be actually of default value, which is 0. But after we perform this save changes, we'll also have an ID to that forecast. Not that it would be very important for us in our Blazor WebAssembly app, as we will see later, but we will have it should we need it somehow. Okay, so right now we have this one, and I see that we have 2 errors. Let's of course we have forgotten, or we have some typos here. Yeah, that's actually it. So I had it, I guess I had a typo there. Good. So we have a get all method, we have a get by ID method, we have a create method, or a create actions. These are actually actions. So the next one is the update. So I would have here a public async, of course. And I also have this typo here, but we'll fix it right away. So async task of action result, of course, and we'll call this very, very simply update. Now, of course, once again, what we'll do here is we'll have to specify that we want to do this via an HTTP put. And what we could do here is we can also specify a route. And the route should be actually, or could be actually, something like, sorry, we just need like this, something like ID. And then what we will have here is we'll get an int ID, yeah, ID, let's call it ID, and then we'll have a weather forecast that is actually an updated version, updated forecast. So let's call it like that. Now what we'll do here in this case, of course, is that we would simply actually update this. So it's very easy actually. Context.forecasts.update, and then we just provide the updated forecast. we don't do any type of checks here. As said, updated forecast, and then we just save the changes. Wait, sorry, this is not with underscore. Context dot save changes async, so that should be it. And afterwards we can just return OK with the updated weather forecast. Okay, updated forecast. And last but not least, the final action that we need to implement here is the delete, of course. So it will be public async task, once again, of iAction result, and we'll just call this very simply and plainly delete. Now this would be of course HTTP delete, and what we want to do here is we also want to specify a route, and then what we can do here is the route. In the route we can get once again an ID, and what we can do here is ID, int ID, and here we have actually to do a few operations. So var forecast equals await context dot forecasts dot where, because we want to look for a specific weather forecast that has a very specific ID. So forecast, we look for a forecast that has the ID, or that should be a dot here, equal to the ID that we get actually from the route, and of course we want to get the first or default async, because we want to do this asynchronously, and that should do it. So now the next thing that we can do is we can simply say right now context.forecast.remove, and we say that, hey, we want to remove this forecast, and then we can just simply await context.save changes async as usual, and that should be it. Now what we can do here is we can return an OK, and in this case we'll return once again the forecast that was deleted, and that should be it. So this is right now our controller. So as said, we have already implemented the data access layer part. So we have a database and we have a DB context that we can use actually to inject in our controllers and write, read, and update, delete things from our database. Then we have implemented the controller actions that we actually need for the basic CRUD, and for that we have the get by ID, the create, the update, and the delete. And last but not least, as said, what we want to do is implement everything in Blazor. So what we need here to do right now is actually to switch over to our Blazor WebAssembly application. And here in our Blazor WebAssembly application, first of all, I want to go here to this program.cs file and show you that actually when the Blazor WebAssembly application starts, what happens here is actually that we create a new HTTP client service that will provide us with an HTTP client already configured with the address of our hosting server, which in our case is this regular ASP.NET Core server. So the cool thing is that we can use actually this HTTP client and inject it into our components, and the client should already be configured. We will just have to provide actually the exact endpoints to which we want to make some calls. And that's actually it for what I wanted to show here in this program file. So now the next thing is what we want to do here is we have this fetch data component, which actually, as we can see, simulates, I would say, an HTTP call, because it actually reads from a JSON file that we actually have in the www root folder. But we want actually to substitute this with some real calls that we will actually make to the API that we have just created. And in order to do that, as said, we can inject the HTTP client, of course, and we can then create other components that we can use, for instance, for create and update our weather forecasts. But before this, since the markup would be a little bit longer, what I would say is that I won't really write down all the markup, but I have already prepared it, so I will just copy over the parts of markup that we need in our Blazor components, and then actually we will just implement the behavior or the code behind part. So the first thing that we want to do here is that in this table we actually want to add a new column, and in this column we would actually just provide some information, or well, we will provide some buttons, actually 2 buttons I would say, for our delete forecast and for the edit forecast. And what we will do here is, of course, we will also need a new button to create a new forecast, and we will create this button right below the table, and that would be actually a green button that would allow us to create a forecast. And of course we get some errors here because these methods here right now are not implemented at all, so we will have to implement them. But before we go further, one thing that we would need here in this code behind part, so we have this private weather forecast array, we can simply reuse it, so no need to change things there. But in order to get things working with our API, we will actually need to inject the HTTP, or the HTTP is actually already there. So the only thing that I would inject, because we want to also navigate around, inject navigation manager, and I promise you we'll do a video on navigation in Blazor in general, and let's call this navigation, and that should be it. And now that this is actually done, let's start and implement things in the code behind part. So first of all, we need to implement this here in this lifecycle method on initialized async that we have in Blazor WebAssembly. And here weather forecasts would be actually HTTP get from JSON async. We want to get a JSON forecast array, which is correct. So the only thing that we will need to change actually here is the endpoint to which we want to make the call. So that would be /API /weather forecast, because our controller is called weather forecast controller, and that should do it. And then of course we need to implement a few methods, and do not lose a lot of time here because this video is already fairly long. I will just paste them here and go through them. So first we have a delete forecast method, which will get invoked when we click, of course, the delete button, and it will pass the ID of the current forecast where we clicked on this button. And based on that, what we will do is actually we will simply say that, hey, we want to delete this, and we'll send a delete request to this API endpoint that we have created earlier, and then we have this state has changed in order to notify everybody that the state has changed and that everything needs to be re-rendered. So then what we need to do here is the other one, which is the edit forecast. And here we just navigate the way to something that would actually be, once again, our new component. So we'll create a brand new component for this edit forecast. And the same thing, we will have to create a new component for this create forecast. So let's take it step by step, and first let's create the one to create a new forecast. So we'll add here a new Razor component, and we'll call this create forecast. Okay. And of course we'll need to perform some changes here, and once again I will reuse things that I already have prepared, because otherwise it would really take too long. But what we have essentially done, we have specified that this is a page, so this is a routable one. So when we want to go to create forecast, actually we will display this component. Then we have this using but it's not CRUD, is Blazor CRUD, sorry. Blazor CRUD.shared. So that should be okay right now. And then exactly as it happened earlier, we just inject the HTTP client and we inject the navigation manager, and that should be it. And then we'll have here actually a very simple form to add a new forecast, and I will add the form here right below the H3 tag. And as we can see here, well, we have a simple edit form component, and this one is actually tied to a model that we'll create just in a while. And on a valid submit, we will actually call this insert forecast method that we will implement just in a few seconds. And that's basically it. We just have then two buttons if we want to navigate back to the list or things like that. So the next thing that we would need to do here is in this create weather forecast is, well, we'll need to, first of all, the model for that, because we need the model to which we actually will bind this form, and that is actually a regular private weather forecast, and just we create a new default, I would say, weather forecast instance, but we will overwrite it very shortly. So what we'll do here is that on initialized, so we'll do an override to this on initialized, because we want to pre-populate the date and time. So that's essentially what we do here. And then we implement actually this insert forecast method that gets called when we click the button that we want to do the insert itself. So what we do here is simply we use this HTTP client, and it's cool that we have these HTTP extensions that actually we can use very easily to serialize and deserialize from JSON. This is especially useful when we work with REST APIs that actually support JSON. So in this case, we just post as JSON. We say that we post a weather forecast. We provide a value for it. We provide the URI, or actually the endpoint to which towards which we want to make the request, and then everything should be fine. And once everything is created, what we do, we navigate away back to the fetch data list. So to the list with all the components that we have. So now we have to create another component for the update, and the update component will essentially be exactly the same form, only that it will actually be blank, or it will be actually be populated with the forecast data based on the ID that we will get from the route. So let's here add a new Razor component, and we'll call this update forecast. Update forecast. That should do it. And here, once again, as we did also in our previous components, we need to inject some things here in order to be able to work with the HTTP client and navigation manager. Here it's using to Blazor CRUD, because this is the name of our project. And then we have the HTTP client and the navigation manager. Let's also add a space into this heading. And then we will add exactly the same form once again. And we'll see the difference actually to the create forecast component. It's essentially exactly the same form with exactly the same model binding. The only difference is how we will handle this actually on the code behind part of our component. Because what we will do here is, first of all, we would need a property for the model binding, which is this weather forecast here that we create. And we also need here a parameter for the ID that we will get actually from our routing. And we see that here in our route, we have specified that we will also route to an ID, which is of type int. So what happens in Blazor is that whenever we get routed to a new component, if we see that we have here this this type of ID, it actually looks in the component for a parameter of the same data type and the same name. While it's important to note this is not case sensitive, so ID non-capitalized would be exactly the same as capitalized ID name. But the data type and the name should be exactly the same, and of course it should be a parameter. And in that case, whenever the routing occurs, what it will happen is that of course the value that we will have here in the URI will actually be put in our property. And this is how we can actually pass data when we navigate from a Blazor component to the other Blazor component. Now, a next important thing that we will have here, and it is a little bit different in comparison to the create forecast component, is that we'll override asynchronously this onInitialized async method, because what we want to do here, of course, is, well, we want to get the information about that forecast. So in order to do that, we need to create a GET request, and we have this GET from JSON async once again to this endpoint /API/weather forecast, and providing also the ID. And this will actually trigger the get by ID method that we have implemented earlier in our controller. And this will actually then return our weather forecast, of course, in JSON format, but here this extension method would handle it. So at the end, we'll have here a final forecast, and it will of course be displayed, or all the information of the forecast will be or are bound and will be displayed in the form that we have right now. The only thing is that the temperature in Fahrenheit is read only, so we won't be able to change it manually. So then the only thing that we still miss here is a method that gets called when we actually want to update the forecast, which say here on valid submit, and we want to call the update method, and this method is still missing, but not for long, because here it is. So it's just a regular async method that returns a task. And as you can see, once again we use HTTP and the put as JSON async method that will simply put or create a put request for API weather forecast, and it will provide a forecast ID and of course the entire forecast that needs to be updated. And once everything is done, we want to redirect back to our fetch data. And actually that should do it. So right now, let's run the application and hope that everything will work correctly. So it will take maybe just a few seconds until we would have our application running. It's because it's the first time that we actually launch it. So yeah, let's make it bigger. And we have an exception here. Okay, the following errors occurred. Attribute routing information. Okay, controllers weather forecast create while processing template API controller. A replacement value for the token API controller could not be found available. Action controller to use or as literal string route. Okay, so I probably have a typo somewhere here. So let me go back here to my controller and let me see what happens. So what we need here is okay, we want to call this get by ID, and I guess that should be right here. It's HTTP get, and we have here this route. Oh, okay, sorry for that. Here's the typo, because here we have the controller name. So unfortunately I wasn't very careful before, because we have to use this actually before. It's API / and then controller here in square brackets, so that should be it. Sorry for that. Happens unfortunately from time to time. So let's run the application once again, and I hope that this time it should actually work correctly. Even though the browser didn't get closed the last time, and it might be some errors there, but yeah, it's still loading right now. Now it's loading, so okay. So if we go and fetch data, we see that it's loading, and right now we see the table, and of course the table is empty because we don't have anything in the database. It's a totally new database. We have configured it right when we started this video. So if we click on create entry, we see that we are here, or we were routed to this create forecast component, and the date for today was already populated with today's date. So what we can do here is, for instance, add here a temperature, and we can add here a summary, winter weather, and create forecast. So we are redirected to the fetch data, and here we see that right now we get actually the list of forecasts. So let's create a new entry, and for this entry, let's maybe choose a new date. Let's go for yesterday, and I don't know. Yesterday, I would say there were 0 degrees. So what we did is actually that I don't think it will work. If we will, but it should work. Summary. Full winter weather. Let's click on create, and yeah, you see that we have this one created. And let's create another one for the day before. And the day before, I don't know, we had something like, I don't know, 5 degrees Celsius, and warmer as usual. So let's create forecast. So right now we have a list of 3 forecasts in total. And then, for instance, if we want to edit this one, we click on edit, and we are redirected to this update forecast component, where, for instance, updated summary. So we have an update, and let's click on update forecast, and we are redirected to this one, and we see that here the summary is already updated. Then let's try to delete this one. So delete. And this time something went wrong, I guess. Let's see what actually happened here. Let's go here on network, and let's click on delete. So I guess we do a request to a wrong URL. Let me actually bring this out. It would be like that. So we are making a request to API /weather forecast/2, and this was an HTTP delete, and we get a error 500 back. Okay, so let's see exactly what we have here on our background. We have, of course, here some errors. Argument value cannot be null. Parameter entity. Okay, so where exactly do we have that? Let's see. What do they say? Okay. So let's go to this delete. So we have int ID. This would be the delete. So forecast await. Let's put a breakpoint here actually, and let's try to run this again. So let's delete and see exactly what happens. So we go here, forecasts. Here we have, oh, we actually don't find it. Okay, so why is this the case? Because we have this forecast with ID 2, and we look for a forecast which has the ID equals to ID 2, and we want this first or default async. So in this case, what happens is that it actually it really doesn't find the forecast, which is unfortunate, because in the update method, yeah, we look for the same forecast. Okay, so I'm not really sure exactly what happens here right now, but maybe I'm missing something. So while I'm doing the video, it's not always very easy to keep focused on what's happened, but the idea is that it doesn't find this forecast in the database, and then of course, since it is a null, we can't really remove it from the database. But actually, let me just look a little bit here. For instance, when we want to get by ID, so it's exactly, we do exactly the same thing, and when we update the forecast, we actually can do that. So there was no problem in doing that, and we used exactly the same thing. So we get the ID. Do I maybe have a typo somewhere? I don't know. These are angle brackets, I assume, for the ID. Okay, so HTTP delete to the route API weather forecast and then /ID. So it would be the route was found, it was correct, the ID was found, but in the database we seem not to find it. Okay, so I guess we won't stick that much right now with this one. Let's maybe just go to the SQL Server Object Explorer just for short. And then in the SQL Server Object Explorer, we can go to the database and just look up. So it would be Blazor CRUD, tables, and then we would have this forecasts. And let's click here on view data, and we see that yeah, strangely enough, we deleted so it was actually, I guess, deleted the first time, but it was not updated in the list. I guess that was actually the problem. The problem is that when we delete it, it actually doesn't update the list. And yeah, we'll try to resolve that just in a few seconds. So let's run that again. And then I would expect in this case that we would be able to simply see only 2 forecasts and not 3 of them. So fetch data, loading, and indeed we see only 2 forecasts, and it's exactly the same if we click here on delete. In this time I think everything will work as expected, only that this list doesn't really get updated. So if we do this, it gets also deleted from this list. And this happens, let me just go quick here back to our fetch data razor component. And here when we say that we want to delete the forecast and we say status changed, that should actually trigger the re-rendering of the front end. But however, unfortunately, this doesn't really happen. But well, we see that actually our CRUD works. So we are right now able to create, to read, to update, and to delete weather forecasts in our Blazor WebAssembly app. And to wrap up, just a short recap about what we did today is, well, we just wanted to implement some basic CRUD operations with Blazor WebAssembly. And in order to do that, of course, we saw that we actually need 3 things. So first of all, we would need, of course, a database and the corresponding database layer, and we have implemented it during this video. Second, we needed the controllers. So we went on and implemented the different CRUD methods in our controller, of course, as controller actions. And last but not least, the third step was to actually go back to our Blazor WebAssembly application, where we have actually created 2 new components, a create forecast component and an update forecast component. And we have reused the fetch data component to actually get some real data via the API and display it in the table, with the only addition of 2 buttons for edit and delete for each of the forecasts, and a create forecast button to create a brand new forecast. And we saw that actually everything worked, except for the end, that when you delete a forecast, even if we have called here status changed, the UI didn't re-render, so that forecast wasn't actually removed from there. But other than this, actually everything is okay, and we have seen how to implement basic CRUD with Blazor WebAssembly and of course an ASP.NET Core API in the backend. This being said, thank you very much for watching. I hope you found this video interesting, and if you think that it would be useful, then don't be shy and then just please hit the subscribe button to this channel and share this content with your peers or friends or anybody that you could think could find this type of video useful in their learning path. That would be highly appreciated, and I would be totally grateful for you. And if you totally enjoyed this content, then just get in touch with me, just drop a comment. I would be happy if you could comment here, and if you have questions, if you have ideas, or just even if you want, I don't know, to criticize this content or challenge it, then just feel free to do it. And well, we're an open community and I really like to get engaged with all of you. So if you feel the need to say something, just use the comments here on this video, because it would also be highly appreciated. So this being said, once again, thank you very much for watching, and until the next time, I wish you the very best.